Waiting times. Okay, so we're going to get bold. So remember that waiting process, you have a success probability P, and you keep trying until you succeed. So you're trying to access a database, and with some probability P to succeed in accessing. So you try until you succeed. You try to send a packet on the internet. You keep trying until you succeed. You try to have a girl. You keep trying until you succeed. Success probability is 1/2 in that case. Okay, and that would be definitely an interesting experiment to try. So waiting times. Now we're going to get bold. Okay, so waiting time. Waiting time. Okay, so you typically try until you succeed. We're going to even, jump straight to the most general case and consider what's the waiting time until you get K successes. So we analyze the case where, the waiting time till you get 1 success. But we could similarly say, I'm going to keep trying until I get K successes. So waiting time to K successes. Okay. So, the waiting time to 1 success, so if X1 is the waiting time to the first success, okay, then we showed last time that the expected value of X1 is equal to 1/P. Okay. But what about the waiting time to K successes? So let's imagine the process where you're waiting for K successes. So you start and then you wait, okay, and you get your first success. Okay, and then you wait, and then you get your second success. And then you wait, and so on, your third success. And so on until you get your Kth success, at which point you stop. Okay, so that's the waiting process to K successes. So let us say that you wait a time X1 for the first success, and then you wait a time X2 for the second success, and then you wait a time X3 for the third success. Okay, now let me be precise here. So the time X1 is the time you wait for the first success. The time you wait X2 is the additional time you wait for the second success. It's not the time from the beginning. And the time you wait X3 is the additional time from the second to the third success. And then you wait a time, XK, which is the additional time you wait from the K minus first success to the Kth success. Okay, so the way I've defined these additional times, we can sort of convince ourselves that the total time you wait is just X1 plus X2 plus X3 plus up to XK. So the total time you wait, let's call that XK, let's call that X. So the total time waited, well, that's just the time you wait for the first success, plus the additional time you wait from the first to the second success, plus the additional time to the third success, plus and so on, plus XK. Very interesting. Okay. So the waiting time, which is sort of, how long do I have to wait for K successes, looked like, a complicated random variable that we might find, we might have a hard time trying to analyze. But now what I succeeded in doing is to massage that total waiting time in a very quote unquote skillful way into a sum. Okay. And so that's sometimes what you have to do. You have to massage what you're analyzing. It may not obviously be the sum. So the waiting time to K successes is not obviously a sum. You have to massage it into a sum. Okay? Why are we wasting our time massaging it into a sum? So that we can apply this powerful theorem. Okay? The expected value of a sum is the sum of the expected values. Okay? I've memorized this thing since birth. Okay. So now that I've got it as a sum, we can just apply the theorem. The expected value of X is just the expected value of X1 plus the expected value of X2 plus the expected value of X3 plus up to plus the expected value of XK. Okay, and now we already agreed that the expected wait until the first success is 1/P. Okay, and so what is the expected wait? What is the expected value of X2? Well, now let's think about it. Okay, so we've waited and we've got our first success. Okay, now we are waiting again for 1 success. Okay, so this X2 is exactly the expected wait for 1 success, where we're starting our wait at this point. Okay, and then we wait, And how long do we have to wait? Well, we wait x2. But in expectation, that's exactly the same as waiting for the first success. We're waiting for one success. So this is also 1 over p. Because we're waiting for one success. And then x3 is waiting for one success. How long do you have to wait? On average, in expectation, 1 over p. So all of these guys are 1 over p plus 1 over p. And now we're experts at this. You add 1 over p n times. This is just n over p. So the expected value of x is n over p. Oh, this is a fantastic result. What are we saying? We're saying that if you're doing this experiment where you're trying, and each time you can either succeed or fail, and you're going to keep trying until you make k successes, so then the expected time to k successes when with success probability of each trial is p. Okay, so the expected time to k successes with success probability of each trial being p is n times 1 over p. So it's just n times the weight to the first success. So let's think about it. Okay. If you're going to have children until you have 2 girls, okay, so n equals 2 girls, okay, and p equals 1/2, okay. So n times 1 over p is equal to 2 times 1 over 1/2, which is 2, equals 4. So if you're going to have kids until you have 2 girls, you will, on average, you should expect to have 4 kids. If you're waiting to have three girls, you will on average be waiting until you have 6 kids. Okay. And the interesting question, what about the expected wait if I'm going to have kids until I have 3 girls and 2 boys? Okay, so interesting exercise. What is the expected wait until 3 girls and 2 boys? I don't know, for whatever reason, a couple decides that they're going to have kids until they have 3 girls and 2 boys. Okay, so a problem for them would arise if, they have girl. They have to keep having kids until they have 2 boys at least. Okay, they could have boy. You see the challenge. Okay, so now I want not just 3 girls, but also 2 boys. What about 3 girls and 3 boys? Okay, so let's be fair. 3 girls and 3 boys. Okay. What about? Okay. So I leave these as questions for you. We'll get to that later. Challenge. Okay. Compute the PDF of X. The PDF of X. And then the expected value from the PDF. Oh, man! It can be done, but it is not easy. Okay? So compute the PDF, the number of trials, until you've gotten k successes. So that has a certain, there's a probability that it's k, then it could be k plus 1, k plus 2, and so on. So you get a PDF for this random variable x. Oh, compute the PDF for that random variable x, and then use the definition of expected value to compute this expected value directly. Well, it's a messy computation, but you will get n times 1 over p. Much easier to get from the theorem. Okay? Let me show you an amusing application of this technique for computing the expected waiting time. Okay? And it turns out, while it's amusing, it's also a very important calculation that we do and that has implications for algorithms in computer science. And it's called the coupon collector. Okay? So let's erase, and I'll come back and tell you about coupon collecting.